Hello, this is Mr. Craig, and I want to discuss some of the calculations here on examples part 3, day 102. The first question says that a certain first order reaction is 73% complete in 110 seconds. The question wants us to determine the rate constant and the half-life for this process. Now, a couple things that we want to really focus on here is, first of all, we know that we have a first order reaction. Also, we know that we have 73% that is complete. In other words, 73% of our reactant has had a chance to react and form products. And we also know that the time involved for this reaction to get to 73% completed has been 110 seconds. Now, one thing that we want to do is, first of all, recognize which equation we're going to use. So since it's a first order reactant, we want to use the natural log of the concentration at some point in time over the concentration that we originally started off with. Now, since we don't have any molarity values here, it just gave percentages. Go ahead and pretend that you're working with a 1 molar substance. That's a little easier to work with or manipulate with. Also, to complete this equation, we know that we are using the equation that has a negative k times the time here. And again, we know it's a negative k because if we look at our graphs and we plot this thing out versus time, if it's a first order reactant, we should have a negative slope. And again, that's what that negative k is indicating for us. So let's go ahead and erase that. Oops. So we know that we should recognize that we're using the correct equation because it has a negative k, and that's what we would expect if we took the natural log versus time. Alright, so if we know that we're 73% complete, what that means is we have 27% of our reactant remaining. And that's the value that we have to plug in for our concentration at some point in time. So knowing that, let's rearrange the variables here so that we can isolate what the K value is, because that's what the first point or the first question's asking here. So you'd find the rate constant, and you need to know the rate constant before you can do anything else with this. So let's rearrange this. We're going to move the T down below. So the equation will now look like natural log of the concentration at some point in time over our initial concentration. Again, all over that. And I'm going to bring the negative sign over as well, just to clean things up. And that'll equals K. Again, to simplify this, go ahead and make this value 1 molar. So if we have a 1 molar solution and we only have 27% of that remaining, what does that value actually represent? Well, it would be, a decimal would be 0.27. So I'd have natural log of 0.27 over the negative time, which again is 110 seconds. And if I type that all in, let's go ahead and get a number here. So natural log of 0.27 divided by negative 110. So I get a K value that's equal to 0.0119, and the unit for this is 1 over seconds. So there's my K. That should say seconds. So that's my K value. That's my constant. So throughout this whole reaction, that is my constant, or my slope if I were drawing that out. Okay, so that would be, oops, erase there. Alright. So we answered the first part. We got the rate constant out of the way. Now it wants us to determine the half-life for this. And again, recall that when we talk about half-life, we're talking about an amount of time needed to get to half the concentration that we originally started with. Well, let's go back up to this equation here. This is our equation that we rearranged here. Since we're looking for the time, let's go ahead and move it back and move K down for our half-life reaction. So that means that we're going to have the natural log of 1/2 over 1. So I'm not going to go ahead and write the 1 there. And we know that our K value is this over here. So 0.0119, and put the unit second on the opposite side. We don't want to have two dividing lines here. And this will give us our amount of time, because again, our unit that's left will be in seconds. So if I take the natural log of 0.5 and divide it by the negative answer from the last question where we had K, that number's still in your calculator, it'll give you a nice time here, which is 58.2 seconds. Now, let's think about this. Does that make sense, or does that seem like a logical answer? Well, if we come back up here and we look at the question, it says that we've consumed 73% of that in 110 seconds. Well, that number that we get for the half-life, our half-life value, better be smaller than 110 seconds. So, yeah, it looks like we did our math right, and that does seem correct here. I'm going to go ahead and make a couple more videos for each of these examples, and I hope that this has helped.